Okay, this is number 4 from the review homework, from the review homework from the first day of classes. So we are on number 4 and we are finding the first and second derivative of the function, and our function in part A is f of x equals x to the 4th plus x, all multiplied by sine of 5x. And there are multiple things going on here. There's a chain rule and a product rule in this one. So when I think about it, this is going to be my function 1, and this is going to be my function 2. If you're writing it out, that means that function 1 is x to the 4th plus x, and 1 prime is 4x cubed plus 1. Function 2 is the sine of 5x, which in itself has a chain rule because it's the sine of 5x and not just the sine of x. So this 2 prime here is going to be 5 cosine of 5x. So when you put that all together, for your first derivative, you want 1 prime 2. So you want 4x cubed plus 1 times the sine of 5x plus 2 prime 1, x to the 4th plus x times 5 cosine of 5x. And now we're going to repeat that 2 more times, one for each of those terms, because again, in each term we have a product and a chain rule. So for the first one, the derivative of that first piece, the 4x cubed plus 1, is going to be 12x squared. And we keep the second term and don't change it, so that's times sine of 5x. Second part of the first product rule, I leave the 4x cubed plus 1 alone, but then I multiply by the derivative of the sine of 5x, which we already have up there in the corner. That's 5 cosine 5x. Okay, so those are the first 2 pieces for this term in my first derivative. So the first term in the first derivative gives 2 terms in the second derivative. Then I'm going to do the same thing for that second piece. So the x to the 4th plus x is going to become 4x cubed plus 1 again. So that means I'm differentiating this one. So plus 4x cubed plus 1 times the second one. We don't do anything to that, so we just get 5 cosine 5x. Notice that those 2 terms are the same. And then lastly, we leave the x to the 4th plus x, and we differentiate the cosine. So that pops out another 5, so that's 25 times the sine of 5x, but it's negative this time, so I'm going to put a negative sign up there. And that means that if I put this all together, I get 12x squared times the sine of 5x. 5 cosine and 5 cosine gives me a total of 10 times 4x cubed plus 1 cosine 5x is my middle term, and minus 25 times x to the 4th plus x times the sine of 5x. And that's my first and second derivative. Then we go on to part B. For part B, we're working with g of x equals the natural log of 2x minus 5 over x squared minus 1. Now, I could jump right in here and do a chain rule and a quotient rule, right? So I could take the derivative of the natural log, which is 1 over what's inside the parentheses, times the derivative of what's inside, which is a quotient rule. But that's working way too hard because the natural log allows me to simplify this. We know that when we have the natural log of a divided by b, that's the natural log of a, which is our top at 2x minus 5, minus, because it's division, the natural log of x squared minus 1. And now I've eliminated the need for the quotient rule. So when I find my first derivative, g prime of x, I do need to use a chain rule because each ln has something that's not just an x, but I don't need a quotient rule. So the derivative of the natural log of anything is 1 over that thing, so 1 over 2x minus 5, times the derivative of what's inside, which is 2, minus 1 over the derivative of 1 over what's inside, times the derivative of what's inside. And that leaves me with 2 over 2x minus 5 minus 2x over x squared minus 1. So that's my first derivative. For my second derivative, and actually I might simplify. So there's my first derivative. The first one I'm going to write as 2 times 2x minus 5 to the negative 1. And the second one I'm going to leave as a fraction. So that when I take my second derivative, the first one just requires a chain rule. So I take the negative 1 times the 2 to get negative 2. I leave the 2x minus 5 inside. And my new exponent, I am subtracting 1 from that. So negative 1 minus 1 is a negative 2. But then I also have to multiply by the derivative of what's inside, which is also a 2. And that's going to give me a negative 4, right? Negative 2 times 2 over 2x minus 5 squared, right? The negative 2 power drops it down to the denominator. Okay, that's just the first piece. Then I have minus, and over here, we're working with the derivative of this, right? Which is a quotient, so we're going to need quotient rule. Derivative of the top is 2 times the bottom is x squared minus 1. Minus the derivative of the bottom is 2x times the top, which is also 2x, all over the bottom squared. So if I simplify that, that's minus 2x squared minus 2 minus 4x squared, all over x squared minus 1 squared. And I can get one more simplification here. The first fraction stays the same. And the second fraction will become, let's see, negative 2x squared minus 2. And then if you wanted, you could distribute this negative and make everything positive. So we get negative 4, 2x minus 5 squared, plus 2x squared plus 2 over x squared minus 1 squared. And that is my second derivative.